Welcome to Samm Plus. This is Samm. Today we are going to be solving this complex exponential equation, as you can see. So stick with me. Let's solve together. Okay. Now, if you looked at this very well, these powers are the same, right? Yes. And if you look at the number, the basis of this same power now, this is 1 over 4 and 1 over 2. We can get a 1 over 2 out of 1 over 2 out of 1 over 4. So watch what I'll do. So I can say this is 1 over 2 square. We have m plus 1 over 3 plus 4 equal to 5 into 1 over 2, and our power is m plus 1 over 3. Okay, from here we can make, in fact, 1 over 1 square is also 1, 2 square is 4, so we can do this next. We can say 1 over 2 all square. Watch you. This 1 over 2 square now is for this 1 over 4. Now remember that we still have a power there of m plus 1 over 3. Good. Plus 4 equal to 5 into 1 over 2 with a power of m plus 1 over 3. Okay, to make this similar to or the same as this, we can remember our law of indices. If you have two, let's say p raised to power x raised to power y, we can multiply the two powers, which will give us p x y, which is the same thing as p y x, because multiplication is commutative. So x multiplied by y is still the same thing as y multiplied by x. So with that understanding, we can do this. Watch what I'll do. 1 over 2 raised to power m plus 1 over 3. And now why am I doing this? I'm trying to make this similar to this so that we can substitute and move on from there, because it's still looking very big. Okay, so remember now I can say multiplied by 2, this same 2, so 3 multiplied by this and this multiplied by 3, sorry, by 2 is still the same. Okay, so plus 4 equal to 5 into 1 over 2 raised to power m plus 1 over 3. Now watch this. 1 over 2 raised to power m plus 1 plus 3 is the same thing we have here. 1 over 2 raised to power m plus 1 over 3 I meant. Okay, so we can conveniently say let's this 1 over 2 raised to power m plus 1 over 3, this now let's call it p. So let this equal to p. So we can say this is our p now, and we have a power of 2 left. Don't forget that 2 from this 2 from this 2. So this is now our p. We have a power of 2 there. So plus 4 equal to 5, and this is what? P. Okay, so I think this is clear. We can move from here. So we can, this is quadratic, so we can rearrange this to become p squared. This 5p, bringing it in, becomes minus 5p. Then we have plus 4 equal to 0. Now this is a quadratic equation in p. Okay, let me bring it up here and solve. So from what we have here, there are many ways to solve a quadratic equation, but let's do factorization. let me bring the equation back here. So our p squared minus 5p plus 4 equal to 0. Now, let's look for two numbers that when we multiply will give us 4, and when we add give us minus 5. So 1 multiplied by 4 will give us 4. 1 plus 4 will give us 5. But now watch what we are looking for, plus 4 and minus 5. So we are going to need minus 1 times minus 4 to give us positive 4, correct? And minus 1, plus minus 4, not 5. It's minus 4, that will give us minus 5. So this meets the condition. So our numbers are minus 1 and minus 4. But when we add them to give us minus 5, multiply them to give us plus 4. So that's the candidate. So let's go. So this will give us p squared minus 1 first. So minus 1p, then minus 4p. That's minus 1 and minus 4 now from here. Yeah, then plus 4 equals 0. So watch, this is our p squared. This minus 5 now became the minus 1p and minus 4p to give us minus 5p. And this plus 4 equal to 0. So that's what we've just done. So now we can group to factorize, but this is called factorization method. So what's common in this bracket? We have p common, we have left p minus 1, then we have a minus. What's common in this other bracket? 4 is common. What's left is p. We have a plus here, but we're going to need a minus 1. Now why are we using a minus? Because this is negative. In fact, if you expand, minus 4 multiplied by p, that's minus 4p. Minus 4 multiplied by minus 1 will give you plus 4. So everything is fine, equal to 0. I will factorize again because p minus 1 is common to both sides. Factorize, so p minus 1, and then what we have left is p minus 4 equal to 0. Yeah, so now remember, when the product is equal to 0, it's either the first, that's p minus 1 equals 0, or the second, p minus 4 equal to 0. It means that p is equal to 1 or p equal to 4. Okay, so p is equal to 1 or p is equal to 4. But now we're not looking for p originally, we're looking for m. Because in our original equation, the only variable there is m, so we have to solve for m. But remember earlier, we introduced p, saying let 1 over 2 raised to the power m plus 1 over 3 be equal to p. And now we have two cases of p, so we're going to try both. So let's go with the first case, when p. So when p is 1, remember this is our p, right? So this is our p. So our 1 over 2 raised to the power m plus 1 over 3 equal to 1, which is our p. And now remember, any number raised to the power 0, the answer is 1. So when you have a 1, it can be put into any other number raised to the power 0. Now in this case, we have a 1 over 2 here. So this one can just be 1 over 2 raised to the power 0. So this will give us 1 over 2 into m plus 1 over 3 equals to 1 over 2 raised to the power 0. And now you want to ask, why did I choose 1 over 2? The truth is that by any means necessary, you need to move forward. And now 1 over 2 raised to the power 0 is 1. So choosing 1 over 2 is because we have 1 over 2 here. So now remember our law of exponential equations. If the bases are equal, the powers have to be equal. Yeah, law of exponential equations. So now that the bases are equal, we can equate the powers. So equate the powers. So this cancels this in our powers. Here are the relevant ones. So our powers now, m plus 1 over 3 is equal to 0. So m plus 1 over 3 equal to 0. So from here we can cross multiply. M plus 1 times 1 is m plus 1. 3 multiplied by 0 is 0. So from here we can confidently say m equals to minus 1. Okay, so we have a value of m minus 1. Okay, but that's not all. Remember, we had two cases of p. So we tried the first one when p is 1. We have m as minus 1. So what about when p is 4? So when p is 4, what do? We bring back our half raised to power m plus 1 over 3 equal to p, which is 4. Okay. So how do we balance this? Okay, I have an idea. This 1 over 2 can be written as 2 raised to power minus 1, right? And then I have our power of m plus 1 over 3 equal to 4 can be written as 2 squared. Yes, I think there's sense in what I'm doing. Now, the bases are equal again. Remember our law of exponential equations. If the bases are equal, the powers have to be equal. So we can simply equate the powers so that this cancels this. Then remember our minus 1 here, don't forget to minus 1 multiplied by m plus 1 over 3 equals to 2. Okay, now if we choose to multiply this by minus 1, it can confuse us. So we can just divide both sides by the minus 1 so that we are free to work. So we can divide both sides by minus 1. You can go ahead to do that if you prefer that method, but I'm trying to make things simple. So this will cancel this. So what we have left here is m plus 1 over 3 equal to minus 2 now. So if we cross multiply, this m plus 1 multiplied by 1 is m plus 1 equal to 3 multiplied by minus 2, that's minus 6. And simply m is equal to minus 6. This plus 1 to the other side becomes minus 1. And m equals to minus 7. So finally, we have two values for m. So our m is equal to minus 1 or m equals to minus 7. Yeah, and that's the answer. So I remain as Samm. Don't forget that my job here is to simplify mathematics for you so that you can use it confidently.